In this video, we're going to take a look at inverse functions, find out what they are, how we use them, how do we find them. Inverse functions are kind of like the game of Jeopardy. I give you the answer, you tell me the question. It's kind of undoing what we did. We're trying to find out where did we start with. So if we look at our function box, has an input. Here's my function f of x, and here's my output. And I plug in some number. And I get out my answer, say 20. Now, if I want an inverse function, I want to do the other thing. I want to say, hey, I got out of this function the number, say, 8. And I wanted to say, what did I plug in to x to get 8 as the output? To do that, I'm going to do my inverse, which I'm going to call f. I'm going to put a little hash up here to say f inverse. Oh no, it's going to be a -1. Kind of like an inverse of multiply is dividing, so we make a -1 exponent is saying take the reciprocal, undo the multiplication. We put a -1 on the f that says that's the inverse function. And so I want a function that does the opposite of f. So I can take this output that I have and plug it in to my input, and I'm going to get out what it was that I first put in the first place. That's the basic idea when we're talking about inverse functions. The main thing with this is we're going to switch the input and the output. So what was the input is now the output. Let's do that. Point. What was the input is now the output. What was the output is now the input. With that basic idea, you can go far. That's really what you need to know to start playing with inverse functions. So let's look at this example. Here's my function f of x, and f of x I've given by this table of values. So if I come along and I ask you to tell me what's f of 4, 4 is my input, so I come over and say, well, when I plug 4 into my function, what's my output? My output is 3. So f of 4 equals 3. That's just function notation. We've been working with it. But if I were to come along the other way and say, what's f inverse of 4? By the fact that I'm put that -1 in there, I'm asking for the inverse function. That means that this 4, the input to my inverse, is actually the output of my function f of x. So I find 4 from the output and say, what's the input? What value gave me 4? And see, the output would be 5. So I would say f inverse of 4 is 5. That's what we're looking at when we look at that inverse. We're saying, I'm giving you the answer, you're fine giving me the question. I'm giving you the output, you give me the input. So if I wanted to come again and say, what's f inverse of 7? F inverse of 7 would be 12. Because the output of f of x, when the output equals 7, my input equals 12. So now let's work with a few other functions. Let's look at this one. F of x equals 5x plus 3. Again, if I wanted to say, give me f of 4, you would just plug 4 in for the x. 5 times 4 plus 3 is 20 plus 3 is 23. So f of 4 equals 23. But what if I came along and said, oh, how about find f inverse of negative 7? What is f inverse? Well, right now we don't know. We'll find out what it is. But since I know this is the inverse, I know my function is f, and this negative 7 is actually the output. So if I'm just doing one value, I could take this and use my function, except plug negative 7 as the output. Negative 7 equals 5x plus 3, and solve that. X equals negative 2. So f inverse of negative 7 equals negative 2. Or in other words, if I plug negative 2 in for x in my function f, I will get negative 7 as my output. But a lot of times it would be nice to just have an equation, have the new function that I can just plug in, because it's always easier to plug into a function than it is to solve an equation. So if I'm going to actually find the function, let's get rid of this here. I want to write an equation for f inverse of x. Again, I'm going to do what we said. The big idea with the inverse is to switch x and y. Switch the input and the output. So I'm going to think of my f of x as my y, and then switch my variables around, and I'm going to get the equation x equals 5y plus 3. And I'm going to solve this equation for y. Now you notice, right now, we're very similar to what we solved when we plugged a number. We plugged a number in here and solved for this variable. We're not going to plug in a number. We're just going to say that's my input, my x. I'm going to solve for this y. So I'm going to do the exact same thing. I'm going to subtract 3 from both sides. X minus 3 equals 5y. I'm going to divide by 5. So I'm going to get x minus 3 over 5. Or, if you prefer, I can say x over 5 minus 3 over 5 equals y. But either way, that's my inverse function. Whoa! Okay, either way, that's my inverse function. That's my f inverse of x, is x minus 3 over 5. And we can check that with what we did over here, where we said, well, what was f inverse of negative 7? Well, that would be negative 7 minus 3 over 5 is a negative 10 over 5 is a negative 2. That's finding an inverse function. So let's try one of these with a power function. Here's my function, f of x equals 4x to the 5th power, and we're going to find f of x, or f inverse. So again, we're going to make this my y, and I'm going to switch my x and my y around. I'm going to get x equals 4y to the 5th power, and I'm going to solve this for y. So I'll divide by 4. I get x over 4 equals y to the 5th. And I'm going to undo the 5th power with, I'm going to go the 5th root on this one. So let's just take the 5th root on both sides. And I'm going to get y equals the 5th root of x over 4, or f inverse of x equals the fifth root of x over 4.